So in this video, we are going to be talking about significant figures, how to determine them and why they're important. Whenever you're taking data, use a measuring instrument. Okay, these can be as simple as a meter stick, a stopwatch, or they can be complicated, highly specialized pieces of equipment. What they all have in common, however, is that they cannot give you an exact value. There's always going to be some uncertainty in any physical measurement. What we have to determine is how many of those digits are significant. Okay, so all of these values, A through G, have been measured. We have to determine how many of those digits or figures are significant. Okay, so we'll use the short form sig figs, but it means the same thing. So starting off with part A, 215. All three of these digits are in fact significant. So we're going to put a 3 there. Whenever you're given a non-zero number, the general rule is that they're significant. For part B, you're quoted a number of 61.60. Now imagine that was 61.6. That would be 3 sig figs. And you don't need to put that 0 there. But the fact that that 0 is there implies a greater level of certainty in the measuring instrument. Therefore, this 0 actually does count as a sig fig, so this gives this a total number of 4. In part C, 7.04, this is another rule. Whenever you have the 0 sandwiched in between two non-zero numbers, this 0 also becomes significant, giving this a sig fig count of 3. In part D, 0.05, this is where it gets a little bit different. The two zeros preceding the 5 are actually just placeholders. They do not contribute to the certainty of the measurement. So in fact, there is only one significant figure here. In part E, 0.0094, same thing as part D. Okay, the zeros in the front are simply placeholders, so that they do not contribute to the certainty of the measurement, giving this 2 sig figs. Part F, 6952, 4 sig figs. They're simply numbers, it's an integer, so that one's pretty straightforward. And finally G, 3200. Usually you find numbers like this with a lot of zeros at the end when they're integers, quoting the population of a city, for example. Let's say the population of Toronto is about, let's say, 1 million. In that sense, they're not counting the individual people, so it's a very rough estimate. And in this sense, 3,200 is also a rough estimate. It's not 3,201, it's just 3,200. In fact, these two zeros here are simply placeholders. Okay, so this gives this number in part G a significant digit count of 2. Okay. And that's it for this video, guys. If you enjoyed it, be sure to give that like button a click and subscribe to this channel so that you never miss a video from me. Thank you so much for watching.